Alrighty. Hi, my name is John Stoltz, and I'm here with Amit Pundir. We both work for the Linaro's consumer group, and we're going to talk about leveraging the past for the future of AOSP Devboards. So just a heads up, all the dates and charts in this presentation are really from our memory, so they're very rough and fuzzy. We didn't have a lot of time to get lots of detailed data and stats, but I don't really want to mischaracterize anybody's work and efforts. So please try not to let any of those inaccuracies distract you. Hopefully the gist should still be accurate. Alrighty, so I kind of talk about this at every Connect, but why is Linaro interested in AOSP Devboards? Well, first of all, it provides kind of this area of overlap where we're able to combine the latest upstream kernels with the latest AOSP, and this allows us to do a lot of different testing, so we can catch and fix regressions, and it also allows us to do development and prototyping of new functionality for AOSP against mainline kernels, which makes it a lot easier to get that functionality upstream. Okay, so now diving into the history, let's start with the first ghost of Devboards past, the Hikey. It was the first 96 board. It was introduced in about 2015 and then added to AOSP in early 2016. It was sort of a mid-range device, could be configured up to 2 gigs of RAM, had proprietary Mali graphics. Now this was basically our workhorse for testing for a number of years, but it was retired in AOSP kind of late 2019. But we still use it actively for testing updates to older LTS releases against those older Android releases. Now, in this chart, we kind of show the progress of getting the board upstream over time. Now, the 100% here doesn't mean that everything that the board can do is upstream, but enough is upstream to make the board useful for AOSP testing and development. So starting off, HiSilicon's landing team did some great work getting the initial board support upstream. About a year later, so they did move on to other work, and that left the Linaro consumer group to complete the upstream. Basically, we got almost all the way. You can kind of see here it doesn't quite hit 100% before turning into this dotted line. And that gap there is basically the Mali driver. Now, Peter Griffin at Linaro did some great work getting the board working all the way with the Lima, the Open Graphics Lima implementation. But for AOSP, we never switched over to using Lima. We're still using the Mali blob driver and rebasing those patches. So it never quite hit 100%. Now, a quick aside, why is upstreaming important? So first of all, it makes regression hunting a lot easier. One of the issues that we have is that when we see a regression, we want to find what broke us. And bisection is an amazing tool for this. The hard part is that git bisect doesn't really work if you can't boot the board at either the good or the bad part. And so, if we're trying to find each step, we have to basically apply patches. Now, we have our own methods to do this, which we call kind of rebase bisection, but it's very fussy and error prone because we have to kind of rebase at every step and do the bisection manually. So it can take a lot of time. Now, another benefit to having an upstream device is that moving to a new kernel can be very easy because you don't have a patch stack that has to be rebased to newer kernels. And when we do those rebases, often you hit collisions and things break. Often we can kind of do it ourselves and fix up things and get it working again. But sometimes it's really hard to do that correctly, especially if you don't have detailed specs for the hardware. So in a lot of cases, little errors can crop in through those conflict resolutions. And this is even harder when we talk about proprietary drivers like the Mali, because sometimes we're testing up against the latest bleeding edge kernel, and if there's kind of a major breakage with the existing kind of kernel interfaces, it may be that the Mali developers aren't anywhere near that. They may be back on an older LTS where their customers are focused, and so we've had to have situations where we kind of help figure out what the right solution is. Work with the Mali team to get that solution added to their driver, and then have them roll a new proprietary blob to release. And that can take quite a while, up to a month sometimes. So it's one of those things where this can be very difficult. And just in general, managing a patch stack is just a constant burden with any dev board. These things really are tools. We want to be able to move on to higher level development. And so this aspect of getting a specific vendor's board support upstream isn't really a goal for the Linaro consumer group. We want to be able to do development on top of it. But the benefits from having a board upstream is so great that we've actually figured it's worth carrying that effort in a number of these cases. So carrying on to the next dev board that we added to AOSP, the HiKey 960. Now, this was announced in 2017. It was very exciting because it was a flagship SoC that had a big little CPU architecture. Now, we worked with HiSilicon and Google prior to the announcement, so we were able to have this in AOSP on the first day of the announcement. Basically, the board was able to be configured with up to 4 gigs of RAM, which was really nice because we were running into lots of problems running Android on smaller memory configurations at that point. It did have proprietary Mali graphics, but it did share some board-level components with the HiKey, so a couple things like Bluetooth, Wi-Fi, and HDMI bridge. I've got a link here to an update from last year that we gave on things that were going on around HiKey 960, if you want to follow that. Now, on the upstreaming side of it, again, as I said, the board did reuse some components. So we were able to leverage the upstreaming that was already done for that, but we weren't starting completely from scratch. But this was a totally different SoC, and so we were starting over, with a big patch stack and really kind of just having to start again. Now, the HiSilicon landing team did some really great initial work upstreaming, but their team's focus did kind of shift over to servers shortly after the board was released. And so this kind of stalled upstreaming for a bit. HiSilicon saw this and committed significant additional resources to try to address this. But unfortunately, right as that effort started ramping up, the trade sanctions took effect and basically halted that effort. So it's kind of been a little static since then. Now, I do want to credit Maro Chahab for continuing to push support for things like USB support upstream in the community. It's great to kind of see that effort still moving forward. Okay, so now I'll pass it on to Amit, who will cover some of the efforts that were going on in parallel at this time.
Thank you, John. Meanwhile, HiKey's success in AOSP renewed the similar interests from other Linaro member companies as well, primarily Qualcomm. So in parallel, we were working with Qualcomm landing team to explore the possibility of upstreaming a Dragonboard family 96 board in AOSP. Our first target board was Dragonboard 410C. It was based on Snapdragon 410 SoC and was already shipping in devices like Moto G4 series. And 10-year support commitment from Aero, it made sure that we do not run into board shortage. Efforts were made to upstream it in AOSP, but 1 GB RAM was just not good enough to keep up with AOSP experience. And we still occasionally support 32-bit AOSP port on DB410C as part of 96 boards community initiative. So backed by the upstreaming efforts from the Qualcomm landing team, 410C was fully upstreamed by 4.14 and was probably the first fully upstream 96 board to run AOSP with Open Graphics Stack. And thanks to Qualcomm landing team, LCG did not have to worry about the upstreaming part as such. However, there are still negative aspects to having to carry a patch stack during development. After 410C, efforts to add a Dragonboard to AOSP transitioned to the next generation board, which was Dragonboard 820C. It was a successor to 410C and a near flagship SoC of that time. Unfortunately, due to priority shifts, the 820C AOSP efforts did not pan out as planned. And like 410C, we do support 820C AOSP queries as part of 96 boards community initiative. And since 410C and 820C share a lot of common blocks, the upstreaming of the board did not start from ground zero. Plus, we could just reuse 410C AOSP efforts on 820C as is. The 820C did get all the way upstreamed, but not before the efforts with AOSP were stopped. Again, we were lucky to have landing team doing pretty much all the upstreaming, but we were still maintaining and rebasing the patch stack against Android common kernels and every RC of mainline kernel for smoke testing. Now, if you take a close look at the upstreaming chart again, especially on the cusp of 2019, you can feel our frustration. We really don't want to be fuzzing with patch stacks forever. If it takes 2+ years to get a board upstream, that's usually longer than their production lifetime. We are getting boards halfway to where we want, and then it's time to jump to something new. Moving to a new board felt more like a never-ending treadmill, and it felt like we were working like crazy, but never getting to the point where we want to be, where we could just focus on higher-level work that would hold more value. John talked about this shortly after this breaking point, and you can check out his presentation, 96 Problems, here. Now, this brings us to the current efforts we've been putting in AOSP lately. After 820C, Dragonboard project got a new lifeline in Dragonboard 845C. It is also known as RB3 and was announced as part of Qualcomm Robotics board initiative. Based on SDM845 SoC, it leveraged our previous Dragonboard AOSP efforts, and we finally got a Dragonboard device landed in AOSP. From upstreaming point of view, out of the box, the board was further along than anything else we had previously started with. Upstream kernel and Mesa support during launch was in much better shape compared to the previous devices. Complete upstreaming, however, still took a little longer than we had hoped, but the board is completely upstream, and we finally got an official AOSP Devboard that just works with upstream kernel. An amazing achievement, so big kudos to Qualcomm, Freedreno, and lending teams. And this has let us focus on enabling additional functionalities like video decoders, camera support, and performance tuning, which makes the board more valuable for testing. And with that, we are now moving into the future. So let's talk about Qualcomm's next generation robotics board, RB5. Based on QRB5165, or commonly known as SM8250 SoC, it is a successor to Dragonboard 845C. For RB5 support in AOSP, we are reusing DB845C build configs. GKI config fragments have already landed in Android mainline kernel, and AOSP launch target should hopefully land by the time this talk is published. Again, the upstream effort on the board was way further along than anything else we had previously started with. RB5 upstream support happened very fast as a result of the prior RB3 and SM8150 upstreaming efforts. The effort by the teams working in upstream projects like Linux, Mesa, and Linux firmware has made RB5 one of the most boring devices to bring up AOSP. Everything just worked. RB5 also highlights how the iterative building and development on earlier work is an important strategy for upstreaming. Android mainline GKI kernel just boots to UI now with no additional patches. The RB3 AOSP user space needed no additional changes or services, and we are even trying to get a single set of AOSP build images to boot on both RB3 and RB5. We are hoping we will have the device fully supported up in AOSP with Android mainline 5.14 pre-built artifacts. Now back to John for the next set of slides.
Thanks, Amit. So like going to a restaurant these days, what can we take away? So I really think that this is very exciting. Linaro has been pushing our members over the years to upstream their devices, and a lot of the members have put up lots of effort to do so. But often the problem is that we'd see upstreaming take, again, 2 or more years, which is longer than most of these SoC device lifetimes. And then, when members introduce new SoCs, they're effectively starting over from scratch. And so they too were kind of stuck on this treadmill, and it's kind of hard to see the value in doing all this. But here we're actually seeing the benefits of upstreaming realized. It shows the importance of this iterative development on building on the previous work. Now, obviously, new SoCs will have new components, but I think one can plan to avoid unnecessary changes. I guess in the early PC days, there was a thing where a lot of hardware would often advertise that it was Sound Blaster compatible. And that was because, there was a lot of software that worked with Sound Blaster audio cards back in the day. And so it was very valuable for new hardware to be able to support those interfaces. And that just allowed this new hardware to work with a wide array of existing software. And so I think there is value in being able to design hardware so that it can leverage the previous software efforts. And the Qualcomm landing team and the Arduino developers have shown that combining this leveraging of effort, along with starting early on upstreaming with a focused team, is really powerful. Another benefit that we see is that the form factor devices like the Pixel 3 and the Poco F1 and the OnePlus 6, those are starting to be enabled against mainline. And that allows us to be able to really compare and contrast the upstream kernel's functionality with the vendor implementations in an apples-to-apples way. So, of course, there's always things that we could wish for still in the future. Some of the things that would be nice to see on an AOSP Devboard would be virtualization support. We'd also like to see better PCIe access. A lot of these boards do support PCIe, but getting to them is a little difficult. So it would be nice to have something like an M2 mezzanine. Additionally, on the recent Dragonboards, the power control is a little complicated. Basically, it pulls voltage from both the USB-C and the DC sources. And so that means that if you want to do a hard reset of the machine, you have to disconnect both power sources. And so this makes it just a little bit of a pain for remote or automated work. And then finally, basically, the bootloader support for Android. Basically, the requirements for Android changes every year. And we can do some of this implementation trying to add this support ourselves, but we also know that Qualcomm is working on these internally. So being able to collaborate in a way would be nice to be able to have kind of the latest bootloader requirements supported on these boards that are a year old or a little older. One more thing is that if we look at the price for each of these boards over time, we can tell that it's really going in just one direction. And with all the inflation concerns, maybe the news should be looking at AOSP Devboards. But that said, especially on these more recent boards, the fact that these boards are fully upstream does make them more valuable long term. So if these boards can last 5 years or so, it'll all amortize out. That said, these are very high-powered boards, and for our testing and development, we're probably not using the full capacity. And so there's probably still an opportunity for a fully upstream but non-flagship lower-cost option. So, in summary, kind of the major takeaways here is that upstreaming is extremely valuable, but vendors do need to be thoughtful on how they iteratively build their platform support. So that they can avoid starting over from scratch on each SoC. Qualcomm and the Qualcomm landing team have done an awesome job realizing these benefits, but it did take a lot of hard work over the years. Kind of the terrible bargain that we've often seen with Devboards in the past is that you buy the hardware today, and there's sort of a vague promise that maybe someday later it will become useful upstream. But maybe that'll happen, maybe not. But if it does, will the hardware even be relevant then? Having a board being upstream when it's initially shipping makes it immediately relevant and valuable. The buyer doesn't have to kind of shoulder the risk that maybe it won't pan out. And so in the end, doing this allows more folks to do innovation with your platform. So we look forward to seeing more vendors kind of realize this benefit and to having a bit of a brighter future here. All right, thank you so much. That's our talk. If you have any comments or feedback, please email us, and we'll hopefully hear from you soon. All right, thank you so much.